Hello and welcome to the session. Let's work out the following problem. It says a stone is projected at an angle alpha with the horizontal. Given that its velocity when it attains half of the maximum height it can attain is √2 times of the velocity at the maximum height, prove that tan alpha is equal to √2. So let's now move on to the solution. We are given that a stone is projected making an alpha with the horizontal. So let the stone be projected from O with velocity u initial velocity u at an angle alpha. Now let AB be the maximum height and PQ be the half the maximum height. Therefore, AB is u square sin square alpha upon 2g, and since PQ is half the AB, so it is u square sin square alpha upon 4g, right? Now if small v is the velocity at P, then v square is given by the formula u square minus 2gh. Now h is the height at P, which is u square sin square alpha upon 4g. So it is 2g into PQ, which is u square minus 2g into u square sin square alpha upon 4g. So now this is equal to u square minus 2g gets cancelled with 2g here, and we have u square sin square alpha upon 2. Now let v1 be the velocity at A. Therefore, S is equal to u cos alpha, that is a horizontal component of the velocity, is u cos alpha at A, right? Also we are given that velocity when the stone attains half of the maximum height is √2 times of the velocity at the maximum height. Here we have v1, and the velocity when the stone attains half of the maximum height, it is √2 times of the velocity when it is at the maximum height. So v is equal to √2 times u cos alpha. So this implies v square is equal to 2u square cos square alpha. Now we have v square is equal to u square minus u square sin square alpha by 2. Let's name this as 1 and this as 2. So equating 1 and 2, we have u square minus u square sine square alpha upon 2 is equal to 2u square cos square alpha. This is from 1 and 2. Now this implies u square into 1 minus sine square alpha by 2 is equal to 2u square cos square alpha. U square gets cancelled on both sides, so we have 2 minus sine square alpha is equal to 4 cos square alpha. Taking LCM and simplifying, we have this, and this implies 2 is equal to 4 cos square alpha plus sine square alpha, and this implies 2 is equal to 4 3 cos square alpha plus cos square alpha. 4 cos square alpha can be written as 3 cos square alpha plus cos square alpha plus sine square alpha. So this implies 2 is equal to 3 cos square alpha plus 1, as we know that cos square alpha plus sine square alpha is 1. So this implies 1 is equal to 3 cos square alpha. Subtracting 1 from 2, we have this. So this implies cos square alpha is equal to 1 by 3, and this implies cos alpha is equal to 1 by root 3. Now cos alpha is given by base upon hypotenuse. So in the right triangle, here base is 1 and hypotenuse is root 3. Now we can easily find out the perpendicular. So the perpendicular is equal to under the root of hypotenuse square minus the base square. So this is equal to under the root 3. Root 3 square is 3 minus 1, and this is equal to root 2. So the perpendicular is root 2. Now the sine alpha is given by perpendicular upon hypotenuse. Now perpendicular is root 2, hypotenuse is root 3. Now we have obtained sine alpha and cos alpha. So tan alpha is equal to sine alpha upon cos alpha. Sine alpha is root 2 by root 3. Cos alpha is 1 by root 3. So this is equal to root 2 by 1, which is equal to root 2. And this is what we had to prove. So this completes the question and the session. Bye for now. Take care. Have a good day.